Hi students, in this video I am going to explain about the activity 6.8. In this activity we are going to see the reaction between the vinegar and the baking soda. In the previous class already you studied the nature of these both the substances. Vinegar means the acetic acid and it is acidic in nature, and baking soda, that is the sodium hydrogen carbonate, it is a basic in nature. When we will add a pinch of baking soda in a vinegar, that time we can listen a hissing sound and bubbles of gases coming out from that test tube, and these bubbles of gases are of carbon dioxide. Means the reaction when occurs between a vinegar and baking soda, that time the formation of carbon dioxide takes place. Now if we will pass this carbon dioxide, which one is formed due to the reaction between acetic acid and baking soda, through the lime water. The lime water means the calcium hydroxide solution. See here, the lime water is a calcium hydroxide solution. This is also a basic solution. If we will pass the carbon dioxide through the calcium hydroxide solution, means lime water, then due to the reaction between carbon dioxide and lime water, the formation of calcium carbonate takes place along with the water. Means whenever we will pass this carbon dioxide through a pipe from the first test tube into the lime water solution, that time that carbon dioxide reacts with a calcium hydroxide and it gives the calcium carbonate plus water. Students, with the help of a next small experimental module, let us understand the procedure and observation of this reaction. Here you observe the experimental procedure of this chemical reaction. First, take the baking soda in a test tube. Cover that test tube properly with a bent glass pipe and a rubber cork, and arrange it properly with a metal stand. Then add the vinegar in it. Then due to the addition of a vinegar, the reaction occurs between the baking soda and acetic acid, and the carbon dioxide gas formation takes place. With the help of a bent glass pipe, collect this carbon dioxide in another test tube which contains the lime water solution, and when this carbon dioxide passes in the lime water solution, that time the reaction takes place between it and the calcium carbonate plus water formation takes place, and due to the formation of calcium carbonate, the lime water turns milky, and due to the formation of these new substances only we can consider this reaction as a chemical reaction or a chemical change. I hope all of you understood the reaction between the baking soda and a vinegar and the effect of a carbon dioxide in the lime water solution, and these both the changes are called as a chemical changes, because a change in which one or more than one new substances are formed and which are having the different properties than the original one, such a type of changes are called chemical changes. So as you studied the burning of a magnesium oxide, again the reaction between copper sulfate and iron, these are also examples of chemical change. And same like this way, so many examples already you studied in a previous chapters that are also related to chemical changes. You have to think about it, then only you can list out so many examples of chemical changes which occurs daily in your surrounding area. For example, the digestion of a food, ripening of a fruits, again the cooking of a food, even the medicine formation. So many different medicines are available in the market. This medicine as a product, when it comes in a market, that time there is a chain of chemical reactions present in the preparation process of medicines. Even the plastic, so many artificial synthetic materials when we are preparing in the industries, that all related with the chemical changes, and these chemical changes also accompanying the following changes also, like the heat evolution, light evolution. Sometimes the heat can be absorbed or given out, sound also produced, and sometimes the color change and smell, a particular smell formation also takes place during this chemical changes. The example of a explosion of a firework indicates the formation of a heat, light and sound, and also the unpleasant gases due to the chemical reaction. Even in our kitchen also, if you will observe, so many chemical changes occurs. If we will cut the apple, brinjal, and for us some time, and if you will observe that slices of a brinjal and apple, after 1 hour or 2 hour, definitely their color change occurs, and this color change occurs due to the formation of a new substance. And here the reaction takes place between the content of this fruits with the air, means the gas is present in the air. So these are also examples of chemical changes. Here, as you know, the ozone layer is a protective shield for the Earth's surface. The ozone absorbs mainly the ultraviolet radiations of the sun rays and breaks down into oxygen, and then only this sun rays comes on the earth. Then here the breaking down of ozone layer into oxygen also indicates the chemical change in it. Next is a photosynthesis. As you studied in a previous chapter, the photosynthesis also related with this chemical change, because there are also so many chemical reactions takes place during the food formation. Now next our point is rusting of iron. As we discussed in a Zoom class, the rusting of iron is also example of a chemical change. In this process, mainly the water water vapor or water and the oxygen, these are the factors responsible for rusting of iron. Whenever the iron material come in contact with the air and water, the rusting process occurs and the formation of iron oxide takes place during this process. And all of you know, so many different type of iron materials or articles used in our day-to-day life. The iron is useful to make the bridges, ships, cars, truck bodies, and so many different machines and the different tools, and also the parts of the electronic gadgets. Now here in the air, whenever the moisture present in air also responsible for this rusting of iron. Now here question arises, then so many iron material we are using daily, then how to prevent this iron material from rusting? Because as we know, this rusting process weakens the strength of the iron material. So it is very important to prevent these iron materials from rusting. For that purpose only we have to give a coating of a paint or a grease on the iron material surface, and this oil paint or a grease, it breaks down the direct contact of a iron material to the air and water. Then another way is to deposit a layer of a metal like a chromium or zinc on iron. Means the process of depositing of a layer of zinc on iron is called galvanization. This galvanization process also helpful to avoid the rusting of iron. In this process, mainly the coating of a zinc or chromium, it is given on the iron surfaces, and the iron pipes now which we use to carry out the water that galvanized with the help of a zinc layer. In case of ships also, mainly this galvanization or this painting is a very important, because as you know, the ships are mainly used for the waterways, means again and again the outer surface comes in contact with the water. Therefore the maintenance of the outer surface of a ship is very important. Stainless steel is made by mixing of iron with a carbon and metals like a chromium, nickel and manganese, and that's why it does not rust. Now next, our point is the 6.4, that is a crystallization, and this is a last part of this lesson. Then this crystallization means whenever a large crystal of pure substances can be formed from the solutions, means mainly from the saturated solution. Such a process is called as crystallization, and it is an example of a physical change. See here, mainly to carry out this crystallization process we need the saturated solutions. As in a class 6 you observed the evaporation process and the salt formation process. This salt formation is also related with the crystallization process, because this salt we get from the salty water, salty seawater, and this seawater salty solution is a saturated solution, and from such a solutions only we can get this salt. So salt formation and evaporation process also related to the crystallization process. Now with the help of activity 6.9, let us understand about the crystallization process experiment. Here you observe the crystallization process with the saturated solution of copper sulfate. Give heat to the saturated solution of copper sulfate and keep adding the copper sulfate powder in it. But after some time, the copper sulfate dissolving, it will stop, because the saturated solution, it becomes super saturated now. And that time, when that copper sulfate will not dissolve in hot copper sulfate solution, that time stop the heating process and pour that supersaturated solution of a copper sulfate in a glass, and in that glass you keep a thread with the help of a pencil and allow it to cool down. And when this hot supersaturated solution of a copper sulfate comes at a room temperature, that time crystallization occurs. Just all of you observe the crystals of a copper sulfate, which we can see here in this supersaturated solution. Solubility of salt in water increases with temperature of solution, so more salt gets accommodated in the solution by giving the heat. The salt from this supersaturated solution gets precipitated out when the solution cools down and it comes to room temperature. I hope all of you understood the crystallization process with this given experimental module. Here in this process, first by giving heat, we converted the saturated solution of copper sulfate into the supersaturated solution. At a high temperature, again the little amount of a copper sulfate dissolved in this saturated solution, and when we allowed to cool down the supersaturated solution of a copper sulfate, that time when it reached to room temperature, then the crystal formation takes place, because the extra amount of copper sulfate which we added during the heating process, that only converted it into the crystal form. So this crystallization is an example of physical change, because here no any new substance formed, only the physical properties changed. That's why this is an example of a physical change. Students, here activity 6.9 completed, and also here the lesson number 6 also completed. So all of you read carefully the lesson 6 from the textbook and complete the given notes properly in your notebook. Now here I am ending this video. So okay,